Hi, I'm Nachiket.
And I'm Preeti.
We're computer science students at NC State and we'll be discussing about approaches to use static analysis tools more effectively. We will discuss problems related to static analysis tools and the risks involved and then talk about proposed solutions and approaches to overcome these problems.
Let us start with our first problem. One major problem with static analysis tool is that a large number of false positive bug warnings have been reported by them. A bug finding tool can only provide significant reduction in the efforts necessary for defect detection if their false positive ratio can be reduced. A lot of tools have to make a trade-off between opting for finding all possible bugs, that is either going for coverage, as opposed to try and find a smaller subset of bugs with more precision. One solution we can use to get over this problem is to prioritize the rules used to find the bugs. Also, the priority of a bug can change from project to project. Example, suppose you have a web application, then we would want to focus on performance related bugs as opposed to a financial application where you would want to focus on security related bugs. So one approach is to find the bug fixes over the history of the project, and any bug warning that was overlooked and then had to be corrected in a bug fix is an indication for a good bug detector. Hence, we can increase the priorities of those bug finding tools, which gives more precision in the subsequent runs.
Another problem is incomplete bug fixes in the bug fixing process. Let us look at an example about incomplete bug fixes. Here we can see a my class which contains a string object, setter getter methods for that object, and a manipulating method. In the fix revision 1, we found that there is no null checking done for that object. So we fix this in the fix revision 1. However, we also see that this fix could also be applied in another method. This fix is then applied in the second fix revision. If some of the related bugs are fixed in the fix revision but others remain, such a fix can be considered as an incomplete fix. The risks involved with this is potentially having to do a lot of rework. One way to solve the problem is by inferring patterns of similar bugs. We can try to warn about bugs that might be related to each other and could be fixed together. Bugs sharing the same project-specific bug pattern are typically related to the same object of the same class. This is an approach for finding related bugs. We have a set of bug pattern templates and we can apply them in a project-specific bug pattern inference technique. These can be then iteratively applied on different fixed revisions of the project to infer more patterns related to sibling bugs that are related bugs, and hence find bugs that could be fixed in the same fixed revision.
Different tools find different bug warnings. For Java alone, we have seen that there are a large number of tools available, like we have PMD, JLint, QJ Pro, Findbugs, etc. A common practice is that if we use two or more tools, each tool typically finds a subset of bugs which might or might not overlap with other tools. For a developer to be sure of leaving out no bugs, he has to use more than one tools, but it is cumbersome to run these tools separately and analyze the results from each. So one solution is to merge the results obtained by running different tools on the same source. In this approach, what we can add another layer, extra layer between the developer and the tools. The layer will take the program to be analyzed as an input along with the defect patterns to be run on the program. Based on the defect pattern, the layer will choose the tools to be run on the program. The results obtained from each of these tools will then be merged to give a priority-based list of the bug warnings.
You can refer to some of these papers to learn about these approaches in detail. Thank
Thank
you.
you. Done.